And the reason that we're having the stamping or printing operation occur at these temperatures is that we want the sapphire lens to be hot enough that it's ductile, which means it needs to be at 1500 degrees Celsius or above. But we actually want it, after it starts to shape itself, to cool off enough to retain that shape. And so the thought would be that we put the boron nitride dye at 1300 degrees centigrade, and we do the entire stamping operation in an oven that's at 1300 degrees centigrade. So we bring this sapphire lens in from a different oven where the sapphire lens was brought up to 1500 degrees centigrade. We bring the 1500 degrees centigrade sapphire lens into the 1300 degree oven, and we press the boron nitride or boron nitride coated stamping into the back of the lens. Since this boron nitride coated device is at 1300 degrees, what it would do is stamp this shape into the lens and at the same time begin cooling the lens off, and it would cool the lens below its ductile temperature, so the lens would become stiff or rigid with these impressions pushed into the back of the lens, and the impressions would not go away, because our next step would be to begin to pull this boron nitride coated stamping device away from the lens. And if you look at the lens, you can see that it has stamped into the lens depressions for all the different structures that were on that boron nitride dye face. And the structures that we've pushed into the boron, the structures that we've pushed into the sapphire lens includes a channel for the gold-filled cross, depressions into the sapphire lens to serve as a chamber or a potential space where the gemstones can sit. The other thing that we have pushed into the sapphire is the lettering of the three-dimensional raised letters. That you will notice that I've shown some of these letters pushed up into the sapphire, and one of the features of SketchUp is that as you get closer and closer and closer to a surface, you just go through it. And now we're on the inside of this sapphire lens, and this is the front wall of the sapphire lens, and this is the back wall. This is the convex wall of this convex planar sapphire lens. This is the planar wall, and you will see poking up out of this planar wall all of these different letters. You will also see these structures that make a potential space for the gemstones. You will also see a potential channel that has been created for the gold of the cross. This is a channel that exists inside of the sapphire lens, and this is a different shape of a protrusion that we put into this sapphire lens to hold the other type of gemstones. And the issue that I wanted to demonstrate to you is that in this drawing that we have with SketchUp, I only have shown some of the letters. And the reason that I did that is because, for some reason, really reflecting that I just don't quite understand how to do it in SketchUp. Pressing letters into the back of something as potential spaces. Remember, these are not letters that are sticking out of the back of this thing. These are letters that are pushed into the back of this thing. The actual back wall of this sapphire is right here. These are letter shapes that have been pushed into the sapphire. And so here is the letter I. Here's the long part of the I, the little dot of the I. This is the bottom part of it. This is the side wall of it. This is the back wall of the sapphire lens material. And these are all upside down because of the way this is written on this sapphire. anyway, if you look at these letters, you can see that I've only done this row of letters right here so you can see it. And the truth of the actual printing, there would be letters here inside the cross. There would also be another set of letters up here. I just didn't put them in because it's so difficult to do that, at least when I try to do it.